This video is to show you how to find the miter angle and the tilt in a compound miter through projections using AutoCAD. For this demonstration, let's pick two planes, or more specific, two elevations, that in plan view they will be joining, creating a 90-degree outside corner. As we can see here, these two schematic elevations, elevation number 1, elevation number 2. Elevation number 1, on a perfectly vertical plane containing a tilt at its right side edge of 78 degrees in relation to the horizontal plane and 12 degrees to the vertical. Elevation number 2, at a slope following that tilt at right side edge of elevation number 1. To better visualize what we have, let's see the following schematic isometric. As clearly as this shows us elevation number 1, vertical, joining elevation number 2, slope. Now that we have seen all this information, let's start our process. The first step in our process will be to determine the depth of the system we're going to be using to fabricate these elevations. Let's pick arbitrarily a 7.5-inch deep system. For this, we're going to be looking at a series of graphics describing the different steps in the process. First, let's describe what is happening with the system at the elevation number 1, the vertical elevation. Let's call for this line to represent the face of the system and this the back. Distance between the two of them, as we know, 7.5. Now with this step done, let's jump to the next, where we'll be seeing what the system is doing at the slope elevation, elevation number 2. For that, let's rotate this 12 degrees of the vertical plane. Now we have rotated and we have obtained this. Notice the lines have been rotated as a unit, where the distance between the parallel lines is still 7.5. Placing a horizontal line, using green color in this case, we can measure and show the inclination degree of the slope, 78 degrees. Also, we are going to proceed to measure from the face to the back of the system over the horizontal line. And the result, this, will be the distance value that we'll be using to create the horizontal footprint at the slope portion, keeping in mind that at the vertical portion will remain unchanged as 7.5 inches. Now that we have established, as mentioned before, the footprint shown with green line for the sloped elevation with a floor plan or horizontal dimension value of 7.668, we can create what I'm going to call the bottom footprint of the miter corner. This is the plan view, or what I want to call bottom footprint, developed, as you may remember, with values obtained in previous graphics. As you can recognize in the left side of the corner representing the vertical elevation, the 7.5-inch deep system. In the other, the slope side, the 7.668 depth. With this done, we all can see that despite this is in plan view a 90-degree corner, the miter angles are unequal, as seen here. And just like that, right here we have the first piece of the information we were trying to get, the miter angles. With the bottom footprint done, from where we got the compound miter angles, now we're going to make use of this and start working toward getting the compound tilt. Needless to say, a footprint in this case is a horizontal plane cutting through the corner. With that in mind, we'll create another footprint which we'll call it top footprint, because it's going to be a horizontal cut or section at a higher point than the bottom footprint. Knowing the angle of the slope, we'll make use of this by placing a projection of such slope starting at the outside tip of the corner layout or bottom footprint. Having this projection in place, shown here in yellow color, we follow and place two more projection lines. One green line on top of the face of the vertical side, representing the horizon. This line may be a projection, but is also occupying exactly the same space as the face of the vertical at that level. In other words, this line is also the same as the one in the bottom footprint. The last line that we have placed here is the red line. We can see this red line is parallel to the horizon, and the distance between them is 3 inches as seen in this dimension. The last three lines we have placed here, the yellow representing the slope, the green representing the horizon plane or bottom footprint, and the red line representing a horizontal plane 3 inches above the bottom footprint plane, which is the green. This red plane is where the top footprint is going to be. 3 inches is just a number that I have chosen for separation between the bottom and the top footprints. Those 3 inches could have been 1 inch, 2, or 10 inches, whatever you want. With these 3 projection lines in place, and knowing that any footprint of the corner along the slope will always be the same, but the location of this will change, moving right as this goes up along the slope. While we are still looking at this image, let me say the next step will be copying the bottom footprint. Moving this toward the right, using the intersection of the face of the slope side with the red horizontal line as the base point. I'm placing this at the intersection of the top footprint, red line, with the slope line. Once this has been moved, change color to red. With those steps done, we can see the new top footprint in red color and in its rightful location. Now that we can see the projections of both the bottom footprint in green and the top footprint in red in the same layout, I can even say twice, because if it's true we are clearly seeing the footprints, we are also seeing the horizontal projections that are 3 inches apart. And those horizontal lines are projections of the footprints. As you know, these horizontal lines is what you will see if you were standing right here perpendicular, standing on the floor perpendicular to the vertical planes. And you will see the green line as a horizontal line starting from this point, and you will see the red line as a horizontal line starting from this point. knowing that these sets of layout are 3 inches apart from each other, now I'm going to be the observant and position myself right here in line with the miter lines of the footprints. Once I do that, I will see those as points. The green point on the bottom footprint, and 3 inches higher and a little bit to the right, the red point on the top footprint. And the moment you have that in front of you, you can make a line between the points, and that will be your tilt. To record that on a clear way, we're going to make a vertical section perpendicular to the miter lines, as long as it goes perpendicular to these 2 lines, which are the miter lines contained on both the bottom and the top footprint, and project that down onto the layout to see and measure the tilt. Here we can see the section perpendicular to the miter lines already projected onto the layout. Now let me explain the logic of this. As we said, we were putting a vertical section through and perpendicular to the layouts or the footprints, both top and bottom, and of course through and perpendicular to the miter lines. Originally, that section was placed here where you see the green line, and that section, the whole section being placed here vertically, was dropped and projected onto the layout by dropping that vertical and making it a horizontal layout. And this red line, it will be the line representing the projection of the top layout, leaving the green line to represent the bottom layout. The last thing to say about the making of the tilt line is the beginning of this should be at the intersection of the bottom footprints to the intersection of the top footprints. Done with this, you can see and measure the angle of the tilt line against the horizon. Let me conclude by saying it can be an infinite reasons for us to find compound miters in corners or unions, and this is only one example. The goal of this video is to point that with the use of AutoCAD, you can manipulate orthographic projections to find information that seems to be hidden, or that otherwise you can only find by using trigonometry or with the use of 3D CAD. If you watched this video and came to the end and did not understand any part of this concept here explained, you can call me to schedule a one-on-one Zoom meeting to go over this application step by step. I will be very happy to help. With this, we have finished this training video. My name is Mario Puel. Thanks for watching.